everyone, it's me again. I'm Lena and I'm from the Healthcare Landscape group. In this video, I'm going to be talking about my third day edition, which is on Exponents Part 5. Now, last week we have worked with this topic, but I haven't made a video on this video yet, and Kennedy had to redo the work for the Exponents Part 5. So this week we're going to also redo the topic of Exponents Part 5. So in this video, I'm going to solve 7 main problems that Mrs. Pratt gave us for our third DE this week. Now, let's start with the first problem. The first problem is parentheses first. 8 plus 6 times 3 minus 8 in parentheses squared will equal what? Now, I've solved this problem, and from the statement that Mrs. Pratt put out for us, parentheses first, I know that I need to follow the order of operations, which means that there's parentheses first and then exponents. So in the parentheses, 3 minus 8 will equal negative 5, and negative 5 then comes the exponents. The next order of operation is exponents. Minus negative 5 squared will equal 25. Therefore, this will equal 8 plus 6 times 25, which will equal 8 plus 150, which our answer is 158. For our second problem, Mrs. Pratt said the rule for the power of squares. The rule for the power of squares. Now, we must calculate the second problem here. We have 27 squared times 13 squared. Now, when I first saw this problem, I thought that there are no relation to either of these. But then I looked closely, and they are both to the power of 2 or squared, which I'll put them both together in the parentheses. 27 times 13 in parentheses squared. This will equal 351 squared, which will equal 123,201. And that is my answer for problem number 2. Problem number 3 states that the rule for the quotient of squares. Now we have 5,000 to the power of 2 divided by 1,000 to the power of 2. This goes the same with the second problem. I saw that there is something similar between these two numbers, which they are both to the power of 2's. I put them in the parentheses, the reverse property of the distributive property, and to the power of 2, this will equal 5,000 divided by 1,000 will equal 5,000 to the power of 2, which will equal 25. For problem number 4. Problem number 4, we have 3 problems. We have A, B, and C. Problem number 4A, apply the text that, I will write it here, x in parentheses plus y in parentheses squared will equal x squared plus 2x, 2 times x times y plus y squared. And follow that statement and apply it with all 3 examples. Now for the first example, we have a plus b squared. This will equal a squared plus 2 times a times b, which plus b to the power of 2, which I just applied. This one pretty easy, right? For the second problem, the for problem number B, it is a bit more difficult. It is 2 times a plus 2 times b in parentheses squared. This will equal 2 times a squared plus 2 times a times 2 times b, 2 times 2b, which plus 2 times b squared. This will, that is what I have here. Now let me show you. It is a bit confusing if I say it out loud, so let me show you what my resolution on paper. Here is problem B, and that's what I said earlier. There's a bit mixed up when I say it out loud, but now you can see it on the paper clearly. Problem number C, the most difficult of all, but we'll just apply the text that I have here on the board. This will equal x, the big parentheses, then the small parentheses, x minus y in parentheses, plus in parentheses, x plus y in parentheses, squared. This will equal x minus y in parentheses squared plus 2 times x minus y times x plus y in parentheses plus x plus y in parentheses squared. This will equal, I just simplified it, and this will equal x minus y plus x minus x plus, y. This will equal 2x squared, and this will equal 2 to the power of 2 times 2x times x squared. This will equal 4x squared. Now, this is the most challenging problem of them all, but we just have to focus our minds onto it, follow this text, simplify it, and then get to 4x squared. The fifth problem, one perfect square that's close to 5,000 is 70,000. Now, what is a perfect square? Take, for example, the number 16. Now, 16 is made of 4 times 4, or 4 squared. And this is a perfect square because 4 times itself is a perfect square. Or we can take 8 squared. 8 squared will equal 8 squared. 8 times 8 will equal 64, and 64 is a perfect square. So one perfect square that's close to 5,000 is, well, if we think of 70 squared, or 70 times 70, that will equal 4,900. But if we take an example, 41 squared, that will have an answer that is bigger than that. So 70 squared is closer to 5,000 than 471 squared. Okay, for the sixth problem. The sixth problem is evaluate. Evaluate this problem. Now we have in parentheses -1 to the power of 2008 plus -1 to the power of 2007 in parentheses times 2 to the power of 2 in parentheses cubed. This will equal -2. Why do we have -2? Because there's two big numbers here. This problem may trick you at first, but if we look at its power, -1 to the power of 2008 will equal -1, and -1 plus -1 will equal -2, and -2 times 64, which is what this number is, will equal -128. That is for our sixth problem. For our final problem, problem number 7. Problem number 7 is, please find the largest number in all of these numbers. Now we have these numbers, and we must find the largest of them all, the largest number. Now, one way to do it is that we will convert all of these exponents out. We will have 2 to the power of 3 and 2 to the power of 4 will equal 2 to the power of 12, which will equal 4,096. Now, let me show it on paper again so that I won't have to say it out loud and it will be confusing. That is all of these numbers that I have calculated out and simplified. As you can see, the largest number in all of these numbers is 6,561. This roots back to 3 to the power of 4 to the power of 2. So we have 6,561 is greater than 4096. And if you look closely at the board, we have 3 to the power of 4 to the power of 2 will be larger than 2 to the power of 3 to the power of 4, and 2 to the power of 4 to the power of 3, and 4 to the power of 3 to the power of 2, and 4 to the power of 2 to the power of 3. And that is my answer for problem number 7. And here are the steps. Simplify the numbers, which I have simplified. Convert the numbers of 4 to powers of 2, which is the second, which is another way to do it. And step 3 is order the numbers from least to greatest. But we don't have to order them because all of these are the same except 3 to the power of 8. And that is our answer for problem number 7. That is all for my video, my DE3 this week for Exponents Part 5. I hope that you learned something from this video, or just review some of the things that you have learned so far from all of the knowledge that you have learned. Thank you again for listening to my video, and I hope to see you in the next meeting or next video. Goodbye, see you again.